Hello friends. So in today's question, figure shows a large block of mass m supporting two small masses m1 and m2 connected by a light frictionless thread. A force F is acting on m such that block m1 is sliding down with an acceleration of a1. Find the force F applied on m and also the acceleration of m, assuming all surfaces to be frictionless. This is a figure. So we have a big block of mass m and there are two small blocks m1 and m2. One is on the horizontal side, another one is the vertical side, and force F is being applied to the mass m, and it is given that m1 is traveling with the acceleration of a1. Okay. So in this case we say that let the acceleration of capital M be a. Let the acceleration of mass capital M is taken as a. Now it is given that m1 travels with the acceleration of a1. Okay, so we can write acceleration of m1 is a1, so m2 will be also traveling with the same acceleration. Okay. So you can say this implies that acceleration of m2 will also be a1. Now let's draw the various forces which will be interacting with this entire system. So m2 will be also moving with the acceleration of a1. Okay. We can say m2 will be moving in this direction a1, and there will be force of tension, and there is single string, so entire force of tension will be T. Okay. Now we are going to have mg because of this capital M in the downward direction, and because of this surface, let us suppose there is a normal of n3. Because of m2, let us suppose there is a normal of n2, and there will be also a m2g in the downward direction, and let us suppose because of this a1 there is a normal of n1, and it is going to have m1g in the downward direction. Okay, so these are more or less forces which will be acting on the entire system, and we say that mass m is moving towards the acceleration a. Okay, we can say that it is moving with the acceleration a. Now let us consider the free body diagram for capital M. Okay. Free body diagram for mass M, and based on that we are also going to write the two equations. One will be in the x direction or horizontal, and the one will be in the vertical direction y. Okay. So let us consider this mass M, small one. So we have n3 in the upward direction, and force is acting this direction, and we have two forces. One is n1 and the other one is the tension. Okay, and in the downward direction First of all we have mg, and then we have n2, and then we have also tension T. Okay. And this is our mass capital M. So these are all the forces which is acting on the mass capital M. So we can say that, and let us take this as x and this as y. Okay. You can see that along x-axis, x direction, we get F minus N1 minus T, and it is going to give a acceleration of A. Yeah, moving in this direction with acceleration A, and this will be MA. Question 1, and along y direction we have N3 is equal to N2 plus T plus mg. Let this be question number 2. Now we draw the free body diagram for small m1. Okay. Say free body diagram for mass m1. Let us say this is our m1. Okay, and there will be T in upward direction. We have m1g the downward direction, and towards we have a normal, that is n1, and there will be also in this direction an acceleration of m1a. And in downward direction it is going to have acceleration a1. So you can say that yeah, we say that along x direction we have n1 is equal to m1a. Question number 3, and along y direction we have m1g minus T is equal to m1a1. Okay, and this is mass m1. Next, we draw the free body diagram for m2. You see that free body diagram for mass m2, and let us say this is our m2, and for m2 we have a tension T, and there is a normal n2, and it is going to have m2g, and it will be also because of the force F, it is going to have an acceleration of, or rather force of m2a, and we are going to take that it is moving in A1 in this direction. You can see that along x direction we get t minus m2a is equal to m2a1, and this is mass m2. Let us call this as, this is our equation number 4. Let us call this equation number 5, and we can say that along y direction N2 will equal to M2G. N2 will be equal to M2G, and let us call this equation number 6. Okay. So first of all, we are going to use the equation 1 and equation 4th. Okay. Yeah, we can simply get the value of t. Okay, so we can see that adding equations, we have 4th and 1 second. Yeah, let me write it here. First equation is our f n1 minus t is equal to ma, equation number 1, and we have n3 is equal to n2 plus t plus mg is equation number 2. Equation number 3 is n1 is equal to m1a, and equation number 4 is given as m1g minus t is equal to m1. This is equation number 4. And 5 and 6 we already have here. So we take equation, okay. One equation we take is m1g minus t is equal to m1a, and second equation we take t minus m2a is equal to m2a1. Okay, then we are going to add them, adding the equations. Okay, so equation 4 and 5, this cancel out, we are left with m1g minus m2a is equal to m1 plus m2. I think I missed something. Yeah, it is A1. This is A1 and this is A1. Yeah, no, it's correct. A1. From here, we can say that m2a is equal to m1g minus m1 plus m2 to a1. And from here we can find out our a is equal to m1 by m2 g minus, and we get the divide 1 plus m1 by m2 by a1. Okay, this is our partially solve for first part. And yeah, next we are going to find out what will be the force. Okay, so we have already the equation that F is equal to, so we use equation number 3 in equation number 1. So using, you can solve this later on also if required, using equation 3 in equation 1, we get, substituting value of n1, we get F minus m1a minus t is equal to, and t we already know is given by the equation 5, we can use it. So using equation 5, or rather we can use also equation number 4. I think we can use mathematics because yeah, using equation 4, and let us call this equation 7. In equation 7 we get, so from here we can write value of t will be equal to m1g minus m1a1. So we put value of t, we get the equation as f minus m1a minus, and we have m1g minus m1a1 is equal to ma. Now it is quite simple, we can simply solve it. We get f is equal to ma plus m1a minus m1g plus m1a1. We can combine if required the like terms, so f will be equal to m plus m1 times a, and this can be written as minus m1. Yeah, so we are going to get this as, rather plus, it will be easier, a1 minus g, and if required we already know value of a, we can put it here and further solve it, otherwise this will be our final answer. Okay. So this is the acceleration of mass capital M, and this is our force acting on mass capital M. This completes the question. Thank you.